Multi-threaded coding has been around in Linux for quite some time now. However, in the beginning there were multiple parallel efforts in place. Around 2002, we had these two main forms of multi-threading support. One of the team stopped their work and then the other one proceeded further. Notice that around this time we did not have multi-core processors the way we have them today. The point being that even before the emergence of multi-core processors, we still had multi-threaded programming libraries. The absence of multi-core processors in those days did not mean we did not have parallel processing. We did have parallel processing back then, and you had at times many systems with motherboards that supported multiple physical processors. However, today we have a whole range of multi-core processors, and they have been refined through several iterations now. And before we move on to multi-threaded programming, you should keep in mind that all of the programming that most of you would have done by now is single-threaded. By single-threaded, it means that by default it would utilize only one core of the processor on a system. Therefore, in order to write programs which are able to utilize more than one processor core, you have to program in the way to do it. That means you have to do something extra in your programs so that your program is able to utilize more than one processor core. There are many ways to write programs which utilize more than one processor core. Multi-threaded programming is one such way. As mentioned over here, multi-threaded programs require very careful program design. The situation is further complicated by the fact that they are more prone to mistakes, and there is usually more effort involved in trying to debug them. This will become clear to you in a few moments. So conventionally, when you write a program, it executes as a process, where the statements that make up your program are executed sequentially, starting from the first statement up to the last statement. Your statements that make up your program are encapsulated in the main function. As you would know, in C and C++ programs, you always need to have a main function. Inside your main function, there can be called to other functions, for example, as A is shown over here. So now for the purpose of illustration, you have, in addition to the main function, you also have the A function written out over here. When the program starts executing, it starts in the main function, the first statement, the next one, and so on. And when there is a call to function A, the flow of control jumps to the code of function A. All the statements which are inside function A, they execute, and the flow of control will then return in the main function, and the statement following function A will start executing. So if I was to trace a path of execution through this code, it starts in the main function. When the call to A function is encountered, flow of control jumps to function A, and then it flows through the statements that make up function A, and then it returns executing the statement after function A in the main function. So this is the path of execution of statements, or the thread of execution of statements. And as you can see over here, there is just one thread, a single thread or a single flow of statement execution. Another way to understand this concept is to assume that time increases vertically downward. So we start execution when the program begins in the main function. We keep going, and at this point there is a call to function A. So the flow of control is going to jump to function A. Function A will execute, and when it is done executing, it is going to return, and when it returns, We come back in the main function, and then the sequence of execution continues up to the point where the main function ends. Now again, you would see that there is a single path or a single thread of statements executing. There's a single flow of execution. There is a single path through all the statements that make up the program. This is your single threaded execution. Now if this program was a multi-threaded program and it was written in a multi-threaded way, then this is how things will be different now. Your main function will begin execution, and at this point we assume that a new thread is formed. And when we form a new thread, we are going to specify the function that should execute in that new thread. So at this point onwards, we will have function A begin execution in a new thread. Notice that at this point, the main function will not pause. It will also continue execution. And this is an important point to understand. The important point is that from this point onwards, you have two functions executing in your program at the same time. You have the main function as well as the A function, both executing in separate threads. So if I was to answer the question, can we say that now there are two functions executing at the same time inside one process? The answer is yes, indeed that is the case. In most books, instead of straight lines, you will see such wavy lines are used to depict threads. So in this process, from this point onwards, we have two threads executing. One is executing the code of the main function, and the other one is executing the code of the A function. So if you have been able to understand how multi-threading is going to look like at the programming level, you would also realize that now there are questions about how these functions will end. What would happen to function A if the main function is to terminate? The other question can be, what should the main function do, if anything at all, in case the A function completes execution? All of these questions bring us back to an earlier statement I made, that multi-threaded programming requires more involved and careful program design. And this can slightly vary depending on what kind of multi-threading library you are using. In the pthreads library, you have to write your main function and your A function, the thread function, and you have to do some extra steps in a highly disciplined way. And these are the things that we are going to now look at next.